Today we're going to talk about implicit differentiation. The key concept is treat y like x but multiply by dy dx. This is in fact an application of the chain rule. So let's go over some basics. We have d dx of x squared is equal to 2x. However, we have d dx of y squared is, applying the power rule, that's 2y dy dx. That's because of the chain rule, because we assume that y is a function of x. Let's look at another example. Derivative d dx of e to the x is equal to e to the x, but the derivative d dx of e to the y is equal to e to the y dy dx. Again, this is because of the chain rule. Another example, d dx of ln x is 1 over x, but d dx of ln y is equal to 1 over y times dy dx. Okay, let's look at an example. Say we have a circle. So here is the equation of a circle with radius r centered at the origin. So we have a circle like this. This is the top half of a circle, which is y is equal to root of r squared minus x squared. And the bottom half of the circle, this is y is equal to minus root of r squared minus x squared. This is the x-axis, this is the y-axis, and that's the origin. Okay, we're interested in finding the derivative of this function. Let's take the top half of a circle, y is equal to root of r squared minus x squared. We can write this as y is equal to r squared minus x squared all to the power of 1/2. Now take the derivative. Let's apply the power rule. That's 1/2 r squared minus x squared, subtract 1 from the exponent, negative 1/2, times the derivative of the inside. Derivative of r squared is just 0 because it's a constant. Derivative of minus x squared is minus 2x. Now the 2's cancel out and we get minus x divided by root of r squared minus x squared. But the denominator is just y. Y equals root of r squared minus x squared. So I can write it as minus x over y. That's the slope of the tangent line, dy dx. And we apply the power and chain rule to obtain that. Now we're going to take a shortcut and use the implicit differentiation. Okay, so to do implicit differentiation, we're going to write this as x squared plus y squared is equal to r squared. And we assume that y as a function of x exists. Okay, so what you want to do is put an arrow where you see a y. This will count the number of dy dx's that come out after you differentiate. This is just a basic rule so you don't forget to multiply by dy dx. But you should always know why you're multiplying by dy dx, and it's really because of the chain rule. Because if you were to write this as x squared plus f of x all squared is equal to r squared, now take the derivative d dx. Derivative of x squared is 2x. Derivative of f of x squared is 2f of x, that's because of the power rule, times the derivative of the inside, which is f prime of x. And derivative of r squared, that's not 2r, is 0 because r squared is a constant. Now we know that y is a function of x and dy dx is f prime of x. So we can write this as 2x plus 2y dy dx is equal to 0. Now solve for dy dx. We get 2y dy dx is equal to negative 2x. Simplify, we get dy dx is minus x over y. And this is exactly the same answer that we obtained earlier when we applied the power rule and the chain rule on this page here. In fact, implicit differentiation is a special case of the chain rule. So all we're doing when we do this is we're finding the slope of the tangent line at a certain point on the circle. So if this is, say, xy, this process finds the slope of the tangent line. Thanks.